next question, number 49. A DC motor has the following specifications: 10 HP, 37.5 amps, 230 volts. Flux per pole is given as 0.01 Weber. Number of poles is 4. Number of conductors, very strangely, 666. Number of parallel paths 2. Armature resistance 0.267. The armature reaction is negligible and rotational losses are 600 watts. The motor operates from a 230 volt DC supply. If the motor runs at 1000 RPM, the output torque produced in Newton meter is dash. Okay, so it's not a multiple choice question. Let's work it out. All the given information is written in a very nice manner in the question itself, so we don't actually have to figure out what's what. So let's just put it all down first. So what's given? We have our flux per pole is 0.01 Weber. Number of poles 4. Then we have the number of conductors given as 666. Parallel path A2, A equals 2. Then the armature resistance RA is 0.267 ohms. Rotational losses PL is 600 watts. Supply voltage V is 230 volts. Speed N is given as 1000 RPM. Okay, so this is all that's given. Now, in order to find out the torque, we have to find out a couple of things before that. So first, let's use all the information given here and plug them into the EMF equation. So I'm sure you're familiar with this equation here. EB equals phi Zn by 60 into P by A. This is our formula. Let's now substitute the values and find out what is the value of the back EMF. Okay, so EB now equals first phi, so that's 0.01 into Z. Z is 666. I don't really like that number. And then we have speed 1000. And we have the number of poles given to us as 4 divided by 60 into the number of parallel paths 2. Now when we solve this, we get a value of 222 volts. So that's our back EMF. Now using the value of back EMF, let's find out what is the armature current. Now armature current I is given by the formula IA is equal to V minus EB by RA. This is from the formula EB is equal to V minus IARA. I'm sure you're familiar with that as well. So just rearranging the terms there, you will have what IA is. IA is equal to V minus EB by RA. So let's substitute the values. We have 230 volts as the supply voltage minus 222, which is the back EMF, divided by 0.267. And that gives us 29.96 amps. So we have the current IA. Now the question gives us the losses. So because it gives us the rotational losses, we can use that in order to find out what is the output power. So the output power, here's another formula. The output power equals EBIA minus the losses. Okay, so that's P naught equals EBIA minus PL. So let's substitute. P naught would now be 222 into 29.96 minus PL was given to us as 600 watts. So P naught should give you a value of 6051.12 watts. So this is our output power. Now from the output power, we can find out the torque now, finally. Okay, so I'll just grab another sheet of paper so that we can work that out. Okay. Alright, now for the output torque. The output torque, tau, the relation is P into 60 divided by 2 pi n. Torque is usually defined as the power output divided by omega. So this. So in expanding that even further, you would have P into, this is P naught. P naught into 60 divided by 2 pi n. Now let's substitute the values. P naught we just found as 6051.12 into 60 divided by 2 into 3.14 into the speed was given to us as 1000. Now solve. We should get a value of 57.78 Newton meter. So this is our final answer, 57.78. So we'll just note that down here. 7, 8. Okay, so this is the entire solution and I hope it has made sense to you all.